Good morning and welcome to the lecture session in the Fourier series of periodic functions of arbitrary period 0 to 2L. So the arbitrary period is 0 to 2L. The definition for that is f of x is equals to a0 by 2 plus sigma an cos n pi by L x plus sigma bn sin n pi by L of x, where a0 is given by 1 upon L 0 to 2L f of x dx and an is given by 1 upon L 0 to 2L f of x cos n pi by L of x dx for n is equals to 1 to infinity, and the bn is given by 1 by L 0 to 2L f of x sin n pi by L x dx for n is equals to 1 to infinity. This is the formula for finding a0, an and bn, and later it has to be substituted in f of x. Let's see the problems now. Obtain the Fourier series for f of x is equals to e power minus x in the interval 0 to 2. Solution: consider f of x is equals to e power minus x in the interval 0 to 2 and it is equated to 0 to 2L. Hence we get the value of L is equals to 1. And we know that f of x is equals to a0 by 2 plus sigma an cos n pi by L of x plus sigma bn sin n pi by L of x. And a0 is given by 1 by L into integral 0 to 2L f of x dx. Where L value is 1, so let us substitute. It is equals to 1 by 1 integral 0 to 2 e power minus x into dx. So we get e power minus x divided by minus x on integration and substitute the limit 0 to 2. That gives us minus e power minus 2 minus of minus e power 0. E power 0 is 1 and minus of minus is 1 plus. Therefore, we are getting 1 minus 1 by e square. On taking LCM, we get the a0 value as e squared minus 1 divided by e square. Now, let us calculate the an value. The an value is given by 1 by L integral 0 to 2L f of x cos n pi by L x dx. On substituting the function and the L value, we get 1 by 1 integral 0 to 2 e power minus x into cos n pi by 1 x of dx. Here we are applying e power ax into cos bx formula. So that is given by e power minus x divided by a square, that is minus 1 square, plus b square, that is n pi square, into a cos bx, that is minus 1 into cos n pi x plus b sin bx. So the formula I will write here: e to the power of ax into cos of bx. The integral of this is given by e to the power of ax divided by a square plus b square is multiplied with a cos bx plus b sin bx. So this is applied where a value is minus 1 and b value is n pi. So when we apply that, we are getting this value. Now e to the power of ax, that is on substitution of limits 0 to 2, e to the power of minus x is taken inside and 1 divided by 1 plus n squared pi square, e to the power of minus 2 into minus cos 2n pi plus n pi sin 2n pi minus of, when we substitute the lower limit, e power 0 into minus cos 0 plus n pi sin 0. In this, sin of 2n pi is 0 and sin of 0 is also 0. So what we are getting is 1 divided by 1 plus n squared pi square into e power minus 2 of minus 1 minus e power 0, that is e power 0 into cos 0 will be 1. So that we have written. Next, let's calculate the value of an. So an is given by e square minus 1 divided by e square into 1 plus n square pi square. That on simplification we are getting it. Now let's go for bn, that is 1 by L integral 0 to 2L f of x into sin n pi by L of x dx. Substitute the value of L and the function which is e power minus x. So here we are applying the formula e to the power of my ax into sin bx. So the formula for that is given by e to the power of ax into sin bx integral is given by e to the power of ax divided by a square plus b square into a sin bx minus b cos bx. This is the formula where a is equals to minus 1 and b is equals to n pi. This is the value. So now when we substitute it, 1 divided by 1 square plus n square pi square and e to the power of minus 2 into minus 1 sin 2n pi minus n pi into cos 2n pi, because the value of x is 2 here. Again, lower limit when we substitute, e to the power of 0 into minus 1 sin 0 minus n pi cos 0. Here cos 2n pi, sin 2n pi is 0 and sin 0 is also 0. Only we are getting n pi into sin cos 2n pi and n pi into cos 0. So cos 2n pi value is positive 1. Therefore we are getting e to the power of minus 2 into minus pi, and this term will be minus of minus n pi into cos 0 is 1. So let us simplify this, and n pi divided by 1 plus n square pi square into 1 minus e power minus 2, or n pi divided by 1 plus n square pi square into 1 minus 1 by e square. This on simplification and taking the LCM, we get e squared minus 1 divided by e square into n pi by 1 plus n squared pi square. Hence f of x is given by 1 by 2 into e squared minus 1 by e square plus sigma e squared minus 1 by e square into 1 plus n squared pi square of cos n pi by 1 of x plus sigma n pi into e squared minus 1 by e square into 1 plus n squared pi square of sin of n pi by 1 of x. Hence e power minus x is given by this expression by taking the common term and simplifying it. This is a required Fourier series expansion. Let's go to the next problem. If f of x is given by 2 minus x in the interval 0 to 4 and x minus 6 in the interval 4 to 8, x plus f of x is a Fourier series, and hence deduce pi square by 8 is equals to sigma 1 upon 2n minus 1 the whole square. Given f of x is given by 2 minus x when the interval is 0 to 4 and x minus 6 in the interval 4 to 8 in the interval 0 comma 8 together. So let us equate it to 0 to 2L so that we will get the value of L as 4. And consider the f of x here. F of x is given by a0 plus a0 by 2 plus sigma an cos n pi by L x plus sigma bn sin n pi by L of x. Let's call this as equation number 1. And a0 is given by 1 by L integral 0 to 2L f of x dx. That is, L value is 4, and f of x when we take 0 to 4 it is 2 minus x, when we take 4 to 8 it is x minus 6. So when we integrate it, 2x minus x square by 2 and 0 to 4, and x minus 6 when we integrate x square by 2 minus 6x, and it is 4 to 8. After simplification and substitution of the limits, we get a0 is equals to 0. Now let us calculate the value of an. An is 1 by L 0 to 2L f of x into cos n pi by L of x dx. where f of x is 0 to 4 and 4 to 8 it is x minus 6. Substitute and apply the Bernoullis rule of integration. So when we apply the Bernoullis rule of integration, u and v. So uv formula is given by uv integral is equals to uv1 minus u dash v2 plus u double dash v3 minus etc. This is what is the formula. So when we integrate it, we get first 2 minus x is as it is, that is u, into integral of cos will be sine of n pi by 4 of x divided by n pi by 4 minus derivative of 2 minus x is 0 minus 1 into integral of the integrated function, that is sine function, will be minus cos n pi by 4 of x divided by n pi by 4 the whole square. The limit is 0 to 4. Now the next term, when we integrate this x minus 6 into sine n pi by 4 of x divided by n pi by 4 minus the derivative of x minus 6 is 1 minus 0 into integral of sine will be minus cos n pi by 4 of x by n pi by 4 whole square. The limit is 4 to 8, and we get on simplification and substitution 1 by 4 into 1 divided by n pi by 4 the whole square, and is multiplied with minus cos n pi by 4 into 4 minus of minus cos 0 plus cos n pi by 4 into 8 minus cos n pi by 4 into 4. In this, this part will be equals to 0 when we substitute the limit as 8 or 4, because sin n pi will be 0 whatever may be the value. Now what we are getting is, on simplification, 16 by 4n square pi square into minus of minus 1 power n plus 1 minus of minus 1 power n. Together when we add 4 by n square pi square into 2 minus 2 into minus 1 power n. Taking 2 outside, we get 8 divided by n square pi square into 1 minus of minus 1 power n. Similarly, let us calculate the bn. It's given by 1 by L into integral 0 to 2L f of x sin n pi by L of x. Again we are splitting 0 to 4, if you split it is 2 minus x, 4 to 8 if you split it is x minus 6. Apply the Bernoullis rule of integration. So 2 minus x into integral of sine is cos, and derivative of 2 minus x is 0 minus 1 into integral of double integral of sine will be minus sine of n pi by 4 of x by n pi by 4 the whole square. Similarly, we do this integral also, that is 4 to 8 also. Then after this, substitute the upper limit and then the lower limit. We get cos n pi by 4, that will be minus 1 power n, and this cos 0 will be there. And here cos of n pi into 8 by 4, it is cos 2 n pi, that is 1, and here cos n pi is minus 1 power n. So all the terms are with a positive and negative term. Here we can observe the first term and the last term gets cancelled, and the middle two terms also gets cancelled. In total we are getting the value of bn is equals to 0. So substitute in the f of x a0 value and the b0 value which are 0 and the an value. So f of x is given by 8 by pi square into sigma 1 by n square and 1 minus 1 power n into cos n pi by 4 of x. This is the required Fourier series expansion. Now to get the deduction, put x is 0. So we get f of 0 is equals to 1 by 2 into left hand limit plus right hand limit. That gives us 2. Next, f of 0 is equals to 2, which is 2 by pi square into sigma 1 minus of minus 1 power n by n square into cos 0. So when we get minus 1 power 1, if we put, it is negative. So it will be 2. And whereas if you put minus 1 power even number, it will become positive and it will be 0. Therefore all the even terms will be 0. Only we get the odd terms. And we can take the 2 common. then we get 1 by 1 square plus 1 by 3 square plus 1 by 5 square. So we are getting pi square by 4 as 2 times of this. Hence pi square by 8 is 1 by 1 square plus 1 by 3 square plus 1 by 5 square, which is a odd terms. Therefore, we can write it in the sigma notation as 1 divided by 2n minus 1 the whole square. That is the required deduction. Thank you.